Right folks, today we're moving on to a Midland 3001, which is come from a dealer in Sheffield. Got a snag with transmit on it, and I'll say it's no reflection on him. I can sometimes not see problems and pass it to Mr. Chippy and he goes, oh, it's that. So it's always going to happen. But if you're on your own, you haven't got that second person to ask. So he's nicely resprayed this in the correct colour. And it's got a wrong screw there. Self-tapper, that's naughty. I'll take both the lids off. So he says no transmit, or dodgy transmit or something. Right, so I can't see anything glaring. You know, the other day we had a situation on the air test with the Unit N100 that we got to scratchy corner and it wasn't coming through as Mr. Chippy as he expected. And whilst he would carry on with the test, I just put a precision screwdriver in the gap there between the insulator and the leaves of the inner of the aerial connector, because it had widened. This one hasn't, but I'm just showing you that can happen. Now on this set we've got actually got a loose SO239, so I'm going to have to unsolder that and solder it up with the 200 watt iron kindly donated by Mr. Benefactor Alan. Otherwise that'll have a transmit snag as well, so that does need addressing. So for now, well, I'm trying to do it finger tight but failing. Anyway, it'll be different with the test gear that it is on an aerial. So we want our standard test mic, power the setup, 13.8 volts, switch it on, and now we're on channel 20, which is fine. So I want the filter out, I want it on DX. We need to have something plugged in as a speaker. I'm just going to check PA. Testing 1 2, testing 1 2, 1 2 1 2. Okay. So when I get a sheet, I'll run this on the extension speaker through our speaker mounted on the wall rather than the test instruments at this point. Switch back to CD. Signal generator on, and where did I put the remote? We'll put picture in picture on, and we'll put on the frequency counter. So 2779125. That's interesting, it's as deaf as a post. So it's the issue the issues with the connector. So if we're going to transmit, it's probably got an issue. It's not going into transmit. So we've got to address that first, because if it goes into transmit, it's going to be a high SWR. So what I'm going to do, we'll put this on a different bench. I'll get the big soldering iron to it, and hopefully it comes back working. Right, so I've rectified that. Let's go over to the camera. We've got no transmit, but it's transmitting from the VCO into our monitor receiver a few inches. So we'll get the RF voltmeter out, just to show you what's happened there, if that's in shot. So it's been removed, cleaned, and the chassis, the nut, the body, all soldered together. That's been resoldered. The capacitor across there, a new piece of wire down because you don't know what strain it's been under, and then to the chassis members there. Whoops, that's the power off. So, where's the RF going? So, I'll go into transmit. It's drawing 270 milliamps, which isn't exactly what we're looking for. So, which is the driver transistor? It's just there. Very small amount, very small amount. So we're not going to have anything there. Very small amount, very small amount. So where does it come from? So it doesn't look like it's getting to the driver. I think it comes from the transistor just here. So if I can just locate where the can is, that's that can. So it's not that one, it's the can back here. We should have a transistor somewhere about here. We've got RF going into that coil. Let's see whether we can tune anything first. That looks to be in the wrong position. Sometimes it's best to use a monitor receiver and tune for the best signal. So you can hear how hissy that is. Okay, so we're going to have a duff transistor, I would think, somewhere, unless there's no power to the transmitter stage. Now, these don't have low power, so it should be permanently powered. We'll prove that with the output transistor, 13.8 volts. So the driver transistor should be the same, 13.8 volts. And without looking at the circuit once again, I would expect that the next transistor has to be powered. So we'll key up. That's what you'd expect on the base. 0.7. And we've got power there, that's fine. So it's going to be an earlier stage. So there's going to be a transistor just there in the wax. Probably about here. Well, you know what? Everything looks right. Everything looks right. Put that to one side for a moment. I'll have a dig into this. Right, so a bit later on, changed the first transistor in the chain. The one I took out read OK, and the one I've put in is a recovered one. We've got a 80 channel illegal AM FM Midland 100M there, and on the 80 channel expansion board is the transistor we want. So we've put that in, and we now have some transmit. So it's now doing 80 milliwatts. And if we go over to, isn't this exciting? We've got 80 milliwatts. Where's my remote gone? Now I know what the clatter was. If we go over to the frequency counter, let's see how on frequency we are. 2779121. So look at that, it's absolutely beautiful. So let's see if there's any other malfunctions. I've had the driver transistor out, 2SC2314, and that reads absolutely fine. And I think the fact we've got that kind of power is that we're heading in the right direction. So it might just be a tune-up. I would think. Start again. So why do I take a transistor out, it reads right, I put another one in, and it works? Well, it's not the first time that's happened, is it? Right, we'll go back to the main meter. So I've pre-tuned those three to get us to where we are. So now we should be tuning on the, there we go, 2.5 watts. Now then, 2.5 watts on 23 megs, not on 27. So I might need a spectrum analyzer yet. Let's just heat that up. Heat that one up. Heat that one up even more. So when it was down there, we were at 27 megs. So I'm going to retune these. So definitely got that tuned to 0.6 of a watt at the right frequency. try and get the right fundamental here. So we're now doing 3.2 watts. And there we go, that's 4 watts, and it's on frequency. I think we'll put the spectrum analyzer on, because that's been a bit iffy. So we'd tune this up solely on power. We'd be on 23 megs right now. Put this on auto. And what's that? 27791185. There's the spectrum analyzer. Let's go looking for some nastiness. Change my glasses. Put 54 megs in. So there's our next spike. Just see which one of these is the one that's going to reduce that. Not really that one. Check we're on the right fundamental here. I'm just looking for second tuning points. Sometimes that happens. Oh, that feels nasty. felt like there was some old debris in there. Let's just put it round the other way. I'm just going to try, we're detuning it to 4 watts there and noting where we are with the spectrum analyzer. I'm going to now go the opposite way and detune it upwards. No, it's definitely downwards. Just look at some of these other coils, which are supposed to be, of course, in a just so position. They've never been touched. Right, so we've looked across there, and that is within the acceptable limits. Let's go back to the main meter. We're on channel 20. I've had a flick round whilst on the analyzer. So we've got 4.05 watts. I'm going to now start filling it for me. Fact. Go to channel 1. .95. Go to channel 40. 3.95. Go to channel 20, and we're at 1.06 amps. The 10th of the 11th today, I really don't know. .27 79121. I'm not touching that because it's right. Not doing that. Usually have to end up putting extra parts in, as I showed before. Deviation. We'll have a look on this meter, but it has a tendency to lie because it needs some service work. Wallow. It's 1. I've got 1.7, but we'll just swap over to the test set behind me. With 3 of these test sets, folks, but this one stays on this bench. I'm not moving them over. Especially not if it's not right. Right, have a look what this says. Wallow. Just give it a little tiny bit. It's 2 point. The absolute maximum is about 2.3. We could just give it a little tiny bit more. Whoa. There we go. So the other test set's lying today. Hope you all like the Midlands Precision Series, because I know there's a 2001 from another customer. Right, so it was actually 2.0 to 2.3 kilohertz. It's now 2.2 to 2.5 kilohertz. Let's see what the meter says, if I can rear it up without. It says it's on the 6. Of course, I don't know what it was before, so we just, you know, just adjust it. So it's now reading 4. So it's a bit dim on the meter lamp, but it's lit. PA's working. Stockets are definitely working. Okay, we'll go over to receive. I'll take the spectrum analyzer off. And instead of having the speaker plugged into the extension speaker mounted on the wall, we'll plug the test equipment speaker in. I've no doubt. Right, just make sure we've got all these controls in the right position. That works. Go to Synad meter, see what we've got. So the 12 dB, 0.88. The 10 dB, 0.8. So we'll do 20, it is 1.7. Squelch threshold. Is 150. 1.5 millivolts. Sorry, maximum we're talking about, not threshold. Let's do threshold now. Threshold is 0.38. That's right, but it's probably going to alter if we go through the receiver. So let's just see if we can get something more out of it. So, same trick as usual. 100 microvolts on the test instrument. Oh, what's the meter read? It reads... It's not far out. Sometimes these are adjustable, sometimes they're not. At the moment it's 50 microvolts. I think Maxon set them at that, but I like them to be 100 because that's industry standard on CBs in the UK. So, it's adjustable on this one by the looks of things because you've got the preset there. Sometimes you haven't, and sometimes you've got the preset on the back of the meter. Depends what the production is, and the date on it is February 82. So what we want to do is we're going to go over to the oscilloscope and we're going to set the detector, and it's I could say the Maxon chassis is the one which is more likely to drift than any other. Don't know why that is, but it just does. But every time I say that, it doesn't need adjusting. Well, it was so tiny that. So goes the sound meter. What we're doing is we want to keep the needle, that's the 12 dB there, to 6 to about 4. The idea is that we're not saturating the receiver with signal, or we can't see the difference. That capacitor looks like it's been hot once. Well, you know, made a tiny difference, such that you wouldn't be able to, no point adjusting the signal generator. Not another? No, there isn't. There can be another where the crystal is on some set. Right, get a new reading. I doubt that's made any difference, but hey, we have to look. I'm off frequency on the signal generator. Going to have to do all this again. Start with the detector. I don't know whether I clonked the knob at what point, you know, so just got to double check. Yeah, it's made a tiny difference, you see. Cyanide meter. About 4. Start again. Right, we'll get that fresh reading. So for 12 dB, oh well, we have 0.38. 0.35. We've actually got 1. Squelch. Set to full. Adjust the squelch till the signal comes in. Adjust. I'll now show the attenuator so you can see where I am. So just open it up a bit again. There we go. And off with the attenuator. There we are. So we've got 100 microvolts there. And we'll just set the threshold. That's too tight. That's too. That's right. It's 2.3. Set the S meter with 100 microvolts on. It's showing a generous like 10, isn't it? So is the preset. It's going to be that one, the extra preset. There we go. It's now set. We'll check the RF gain works, and to do that we switch it to local, which switches in the RF gain, and we can see that that then affects it. Back to DX, and then it has no change. I think it's a good idea, making it switchable like that. So there we are. This is 8043. .427. Now we'll make sure it still transmits. It does. And we'll swap that. I've already checked the aero socket's been tightened. Precision screwdriver, I think I showed you this, down there. I think our aerial plug's been in and out so many times that it's a bit slack itself. It's probably got wear on it and it's showing this fault up. So it may not be a problem with the users, but at least it's showing up here and not when they get the sets back. So I don't really want to take the plug, I don't want to change the plug here because I think that's now a good thing that's happening. One and a Roger. $19, Roger. You'll be lucky, Mr. 21. So I'll put the lids on that. One's a bit dry joint. You know, I'd love to know when some of these sets last work properly. You know, they must be coming out of the woodwork from all over the place. We're servicing about 300 sets a year, have done since 2014. It just makes you wonder, they're all somewhere, aren't they? So we'll go now to the internal speaker. Yep, that works. Now, whether we've got any silver screws is anybody's guess. I'm not putting that self-tapper in that came out. That's a push-in screw. That's probably the one the self-tapper's been in. Let's try. Yeah, that's basically, it's opened up, hasn't it? The only way to do it is to put the chassis on the vice and start bashing away at it, but it's been too nicely redone. See if we can find one other. You know, we scrap illegal radios and we end up with screws, so So I've changed the transistor back to what we were doing. I changed that transistor. The one that came out said it worked and was a gain of 100. The one I put it out in had a gain of 75, but actually worked, and the one with the gain of 100 didn't. So, you know, there we are. So thanks for watching. Trade repair, Midland 3001. See you what's tomorrow.